Welcome. This is the D2 Incorporated demonstration video for our new product, the Water Separability Instrument, or WSI for short. This device is used as a replacement for ASTM D3948, which is defined as the standard test method for determining water separation characteristics of aviation turbine fuels by portable separometer. In this video, we'll walk you through the operation of the device and explain some of the new and exciting features.
As you see, this is the unit. It's a self-contained unit. It has several waste jars, a solvent bottle with IPA, and a water bottle, all self-contained. It runs off AC power, has a universal input, and as you see it comes right up to a welcome screen. I'm going to start a test running and then talk about the features of the instrument as the test is running, which we'll show fairly self-evident in the demonstration. It's a touch screen panel display. There's some resources for diagnostics and other functions. But to run a test, we just start. Now, the test screens are fully self-explanatory. They tell the user exactly what to do next, so there's no confusion. It's a very simple device to operate, no specialized training at all. This is the data screen. You can enter an operator name, the sample number, and the filter ID. The date's filled in automatically because it's a real computer and has date and time. And if we go to the next screen, it tells us exactly what we need to do. And right now it is also sending all that information out through a USB port, and it sends all the test data so that if you want, you can log everything on a remote computer. This is the sample container. This is a sample from, say, a fuel rack or a tank farm. And we use 175 grams of fuel, about 200 milliliters. Just pour the fuel in the sample container, and we put the sample onto the unit. And we can just go to the next instruction. The next instruction is to lock the sonic wand down into the fuel, which is done quite simply like that. The next instruction is, this is a disposable filter, which has 5th edition materials in it, and you simply, it has lure lock fittings. It just sits right on the device like that. There's a internal device that locks it in place during the test. And that's it. The instrument is ready to run. It starts by running some solvent through the detector to clean. The solvent, as I mentioned earlier, is IPA. The instrument keeps track of how much is in the waste bottle, how much is in the water bottle, and how much is in the solvent bottle. And it will warn the operator at the beginning of a test if he needs to make any changes or fill or empty the waste bottle. Now, the unit runs by putting water into the fuel, blending it ultrasonically, and then we run the fuel-water combination through the filter and determine how much water is allowed through the filter. And as you know, filters are designed by surfactants, so this is really a test to understand the surfactant loading in the fuel. So the test starts by pumping some fuel through the system to clear the air out, flush the detector along, and flush any of the last sample out. And now it's started injecting water into the fuel. And as it injects the water, it runs the sonic mixer to start the emulsion process. We inject about 300 parts per million. It's done by a precision pump. And you'll see that the ultrasonic mixer turns on and off. And this is to allow any large droplets of water to fall back down to the bottom of the sample. And then when the mixer turns on, it sonifies those and breaks those apart. And this is critical because what we really want to have is an emulsion of the fuel and the water such that the water is in known sphere sizes of about 10 microns to 20 microns. And we've actually studied this. And with the sonic mixer, the advantage is we have a known power and we get to a known blending. So this is a very powerful part of the technology. The other aspect is we have this precision platinum thermometer in the sample, so we can make adjustments in the computations for the absolute value of the fuel sample as it enters the process, because, you know, coalescence is an electrostatics process, and of course it's temperature dependent. So once the process of mixing is complete, you can see the fuel now has gotten to be kind of cloudy. Here's the original fuel. And when it's completed, we will actually have a stable emulsion. It will actually stay that way for quite some time. We've actually seen them stay stable for days. The first step of the process is to pump that fuel water mixture through the sensor, through the detector to establish a baseline, allows us to correct for any variations in the color of the fuel or variations in the absolute volume of water that made it into the beaker or the absolute volume of fuel that was put in by the client. Then the second part of the test, we pump that through the filter and we start to look for whether we see the water mixture coming out of the filter. And of course, if the filter is being disarmed by surfactants, you'll start to see more water. Now, the detector in this instrument can actually detect water at about a half a part per billion because we use a special indicator and we do this optically. But of course you have to remember we put 300 parts per million water in the fuel, so if we translate the detector sensitivity to water sensitivity in the fuel, we're actually able to detect less than 1 part per million coming through the filter. And that's out of 300 parts per million that start. So we have a tremendously strong dynamic range. And in just a minute, the instrument will switch over from its mixing mode over to its sampling mode. And that'll begin, you can tell, because it'll start plotting the data on the screen. I think we have one more mixing cycle. So to go back over just what the expendables are, we use IPA laboratory grades, so that's local. These water vials that can be supplied by us from the user with the indicator in them and the disposable filter. So the cost per test will be significantly less than the current cost per test. Okay, I think while this is running, we're going to have some questions in regards to the instrument.
Just while the mixing is finalizing, what type of fuels can this device be used to measure?
Well, right now we've started with aviation turbine fuel. We're hoping to eventually be able to do both that and diesel fuel under the ASTM D7261. But for right now, we're focusing on aviation turbine fuel. And I just want to point out here, we have started the reference time, and you can see that this is the response of the detector to the fuel dye mixture. You can see it's a very strong response, and it's stable. Now, it's not going through the filter right now, so we're actually using this first piece of information, which is the baseline, and the second piece of information is the intensity of our water dye solution in the fuel. Is there another question?
Yep. Is the WSI an ASTM D3948 listed device?
No, at the moment the instrument is not ASTM approved. It is undergoing ruggedness trials. We have a task force under the subgroup on fuel cleanliness, J6. That task force is chaired by Kevin Bowers of BP. We expect to finish the ruggedness trials by June this year and present information in Berlin. And we fully expect to be performing a full ILS in the fall. So it will probably not be in a method until sometime in 2014. Getting back to the process as it runs here, now you see we switched over again and we flushed the detector, and now we are running the fuel through the filter. And you can see this time that the detector is not responding because at this moment in this filter, all the fuel, the water that's in the free water in the fuel is being removed. So we're at our baseline number. And as this test goes on, we'll see how this fuel performs. I'm not sure where this came from, but if it's a very low surfactant fuel, you can expect this baseline to be stable for almost the entire test. And then as surfactants come online, you'll start to see that it'll drop away. And the information is both the amplitude of what it drops away, when it starts dropping away, and these are all important, and these are all put in our model, and we use all that information to derive the actual value, which really separates this from the original unit, which was really just a 2-point data. We actually see the entire history of how this filter is performing with this fuel over time. So we feel this will be much more replicative of what a field filter standard. Are there any more questions?
Yep. Every time you run the test, what are the disposables that need to be replaced?
Well, simply, it's really only just the expendable filter. There is a little use of the water. This is a 10 milliliter vial. We use about 70 microliters for every test. But it's a very low cost solution, and the filters will be very low cost assembly.
Is there any long-term maintenance involved with this device?
Well, the unit can be calibrated by the method. The original water separability method has a calibration process by which you take a clay-treated fuel and you treat it with a known surfactant and you get known responses. We do expect the instrument to be calibrated on an annual basis for things as like the temperature calibration, pump rates, some other various factors. So it may be annual. We strive very hard here from an engineering standpoint to make instruments that don't have to come back to the factory. And you can see this fuel is a very low surfactant fuel and it's performing excellently, and almost all the water is coming out, and you can see we're getting near the end of the sample. Is there any more questions?
Yes. When will this device be commercially available?
Well, we may have some sales of the device later in 2013. Of course, it won't be approved yet, but principally those sales will be to people that are working with us and with the ASTM and with the EI and are participating in the interlaboratory study. We'll also have some units out in the field because we're very interested to see that this device correlates well with real filter stand behavior. So feel free to get a hold of us. We'd love to have participants in our study. We will have a number of the units around and available for that.
Due to improved technology, what type of accuracy improvements have been incorporated in this device?
Well, I think I said earlier that the real difference between this device and the existing technologies for making these kinds of measures is this is fully automated. So the entire human interaction with the machine and the measurement has been removed from the process. So the process is very controlled. Pump rates are controlled at times, and they're all done internally by the machine. And so it has a much lower user-to-user variability than a process where you're handling samples and moving things around. But most importantly, this is a true evaluation of filter performance. We're really looking at the actual water that's passing through on a point-by-point basis. And its baseline, you could see the large response that we had without a filter, and then that very flat line, complete cleanliness of the fuel with the filter. So that would give us a very clean end result. And so that would be a very high WSI value fuel. And so that's the process, and you're basically complete. You literally, the gas wand comes up, you have a little residual fuel to dispose of, and you dispose of the filter, just throw it away, and you're ready to do the next test.
Thank you very much for watching our D2 Incorporated WSI demonstration video. If you'd like any more information on this piece of equipment or any of our other pieces of equipment, please visit our website at www.d-2inc.com, or you can please give us an email at mail, that's mail, at d-2inc.com. Thank you again for watching, and we hope to hear from you soon.